Good morning, everyone. I think we'll start. I think we've got lots of people logged on that we're planning to attend today. Welcome to another one of our regular webinars that we've been doing. This one is System Platform, Object-Based SCADA. First of all, I'd like to just check that everyone can see the front page of the presentation. It should say System Platform, Object-Based SCADA, Paul Edwards. Can everyone see that?
Yes, I can.
Yes.
Yeah.
That's right.
I'm not seeing that. I'm still getting the 1 moment piece.
Okay, well, it should come on in a matter of seconds. What we'll do is we will mute everybody's phone line so that you should just be able to hear us. It's quite important that we do that because it cuts out any background noise that might be going on in your offices. But what we will do is we will unmute the lines later at the end of the presentation for questions. So I'll just mute the lines now. Is everyone able to see the first page now? Yes? Okay. Right, I'll mute the lines now.
Alicia has muted your line.
And like I said, everyone's muted now, and we will have questions at the end of the presentation, so we'll unmute all your lines at that point. You can also type questions in the chat box. You can direct those to the host, and again, we'll answer those at the end of the webinar. We will also be recording today's webinar and posting it on our website, so you will be able to download that probably later on today. That will appear. We'll email you also, let you know when that's available, and then you can download it, view it at your leisure, or forward it on to colleagues, other people who might be interested. Right, so we'll start off. This webinar today is hosted by Paul Edwards. Paul has joined Wonderware UK and Ireland from an ArchestrA Certified System Integrator, and he brings with him 15 years experience of implementation and management of projects for a wide variety of industries. Paul has managed, developed, and commissioned solutions using many different PLCs and technologies, and has huge experience of using InTouch, Historian, the Industrial Application Server, and Information Server in real-world situations. So I'm sure you'll find today very interesting. I'll pass you over to Paul now.
Good morning, everyone. The idea behind this morning is just to give everyone an overview of System Platform. It's such a huge subject that we're not going to cover it all in half an hour. But what I do plan to do is an introduction, a short demo. We'll talk about licensing, a little bit of a case study, and then we'll do a summary, and then we'll open up for questions. So, leading straight into it. If we look at where SCADA has come from, when SCADA was first developed, it was mainly put on a local machine, and the idea was to allow an operator to control that local machine. But as far as linking to the outside world went, that was about it. The rest of the business was probably run on paper. Somebody may come around to that local HMI, take some readings, note them down, and go away with them, and that was about it. These days, there's a lot more to a SCADA system. A SCADA system's run across a whole enterprise. You have different people in different roles who want to look at their data. So not only have you got operators controlling the machines, you've got maintenance technicians, plant managers, etc. all want to see that data, and they want to see it in the way that suits them. Also, within the manufacturing environment, we have a number of issues to solve. Now, historically, in order to solve that issue, we released a different product. So, for example, for batching, we have a batch product, SPC, there's an SPC product, And this is the way that Wonderware and most other manufacturers have gone. Now the trouble with this is when you want to make a change to one of those products, there are changes that need to be made to other products. So for example, if I change my HMI, I need to change the configuration of my historian for those extra tags. If I change users, then I have to change it across all of the products that I've got. Now the idea behind System Platform, or one of the ideas, is it becomes a centralized development environment for making all of, for configuring all of these products. So from within System Platform at the moment, we can configure our historian, we can configure our HMI, we can configure OEE using our performance module, and we're getting towards being able to configure the other products. For example, when the next release of InBatch comes out, then that will have a lot of work done from within System Platform. So what are the components of System Platform? System Platform consists of a number of components. The first component is device integration. Now this is the connectivity to the PLC devices. Wonderware is famous for its connectivity and the fact that it's not tied to any single PLC device. The main brains, if you like, of System Platform are the Wonderware application server. Now the application server takes data in via the device integration objects and processes that data via scripts and makes that data available to clients on the network. We also have the Wonderware Historian. Sue did her Wonderware Historian, which was the first WebEx that we did, but Wonderware Historian is very tightly integrated into System Platform, and I'll talk a little bit about that later. And we also have the Wonderware Information Server. The Information Server is the web-based reporting portal. Now we're not going to cover that in any detail today. That's being covered in the next WebEx next week. So if we look at how we build a traditional SCADA system, this is for InTouch, but it covers most SCADA systems. We have a number of different parts to build in our SCADA system. So we have our tag name database, which has our links out to our I/O. We have screens that we have to build. We have to put in scripts to manipulate data. We also have history, and we have security, users, alarms, groups, all of those sorts of things. Now with the release of InTouch version 7, we were able to split the windows away from the rest of the application, and this was known as remote referencing. Now this allowed us to build architectures which were tag server clients. Now this is still a very valid architecture and still a lot of people do it. So it allows us to have our tag server application, our history is done by a historian, and then our clients are done with applications that just effectively contain screens. Now if we take the valves that we configure in this application, we have to configure points in multiple places within both of the applications, both the client and the tag server. And if we take multiple valves, we have lots of points of configuration. The idea behind System Platform is to say, take that valve and make it an object, and encapsulate within that object all of that configuration information. What's more, we can derive that object from a template object. And with the latest versions of System Platform, we also make our InTouch applications into objects. And that again is derived from a template application. Just taking that a bit further, we have our valve, which is shown here. Associated with our valve is the I/O, any scripting, any historical information, security, alarms events, and our graphics, and this is done via ArchestrA graphics. And this allows us to derive objects. So, for example, we create a generic object to represent our generic valve, and that's our template. Now, we know from real life that you'll never have two exactly the same, or not every instance will be exactly the same. So you might derive another template from that template, which is a type A and a type B. And from that type A and type B, you derive all the instances, which represent the valves that you have on your plant. So what you can do, you have change propagation. When you make a change either at the generic valve level or at the type A and type B level, that change will then propagate through to the instances that are derived from that template. What we do is we create the templates for simple bits of machines, so for example motors and blowers, and we group those together into contained units, which represent a more complex bit of plant. So you see here from the toolbox we've made a brew kettle which consists of an agitator, an auger, an inlet valve, etc. So by this method we're building up more complicated bits of plant that we can reuse when we build our application. So we take those objects which we've derived from our template and we store them in one global configuration area, which is called the galaxy. So this is done by dragging and dropping from our templates to create our instances. And this goes to actually build up a plant model, which looks like a physical representation of the plant. So you have areas within the plant, for example, you've got roasting, and within that roasting area you have roaster 11, roaster 22, roaster 23. So when you're actually drilling down to find an asset within the plant, you can drill down through the model and find it in a logical manner. Once you've created your configuration and modelled your plant, you then deploy that configuration out to the machines that are going to run those objects, which are called object servers. So you can deploy objects from the central location, and you can have multiple development stations working on that configuration out to your object servers and out to the operator stations. Now it's shown here that operator stations are separate from object servers, but that doesn't necessarily need to be the case. You can have objects and operator stations all on the same node. So what this allows you to do is build a standard object that can be applied to multiple PLC types and allow you to monitor various plants with standard metrics. So you can have standard reports, standard visualization, no matter which PLC you're connected to. So that's a bit of background about System Platform. We talk about System Platform being at the heart of the Wonderware offering. It's used across many different industries, across water industries, across discrete manufacturing. We've talked about the connectivity. It connects to hundreds of devices, not only through its own DI objects, but via third-party OPC servers. We talk about the scalability. System Platform starts off as a single node version, all run on one machine, and then can increase in size to a million I/O version, which can run across a complete enterprise. The interface to System Platform, there are a number of interfaces. So operators will use InTouch to interface the System Platform. Planners may use the information server to view reports. Maintenance personnel may use Active Factory to view the data from the historian. So some of the features that you get with System Platform. It uses Windows operating system security. That's optional. It can use its own security as well. But you can apply that security at both design time and runtime. And what that means is that you can limit which users have access to template objects as well as runtime objects. It integrates to the historian a lot more tightly than an InTouch historian system. When you select a point, and this will be shown on the demo, of an attribute of an object to be historized, that history is automatically then pushed to the historian. As well as this, each node acts as a local store forward. So if the link to the historian is lost for any reason, the local data will be buffered, and then when the historian becomes available again, it will all be pushed forward to the historian, so you don't lose any data. You can develop a system platform project much quicker than you can develop an InTouch project. With InTouch, you're limited to only one engineer being able to develop at any one time. With System Platform, you can have multiple engineers developing multiple objects. Each engineer can only work on one object at one time, but they can check that object out from the IDE, make the changes to it, and then check it back in. Those changes are then logged as well as part of the change control. It's centralized development. You have a central repository, which is called the Galaxy, which stores the configuration, and all the objects are deployed from that central node. There's built-in redundancy. Unlike InTouch, where you have to do scripting, with System Platform, you connect a dedicated network cable between the two nodes, and then you enter the IP address for that dedicated network cable and check a checkbox. And that basically is how you do redundancy. And with the redundancy, you can do load sharing, where you run some objects on one server, one on another, and they can all fail over to one. Or you can just do complete redundancy, where one server sat waiting in case the other fails. It has much more powerful scripting than InTouch. It does use traditional InTouch scripting, but it also uses script based on VB.NET. So you can use a lot of .NET calls within the script, and you can actually mix and match InTouch and .NET scripting as well. It uses InTouch to visualize. The ArchestrA graphics that are created and used are put into InTouch, and anybody who knows InTouch from about version 8 will know that you have an access name called Galaxy built in. This is to link to System Platform. It's scalable. Once you've purchased the System Platform, and I'll go into licensing later, you can then add additional nodes just by purchasing a platform license, and you can move objects between nodes. When you move those objects between nodes, you don't have to then go to your SCADA application and point them at a different node. They know which node the data is coming from. A big thing is, when you are making a change to a System Platform application, for example, you're adding a new valve, then the change is only for the object that you're deploying. The rest of the system carries on running normally. Now, if you think about a SCADA application, when you need to make a change, you have to stop the SCADA application, load a new application, and then restart that new application. And meanwhile, you're hoping that you haven't changed anything that was in there and running and the way you wanted it. You don't have that issue with System Platform. When you need to change a standard, I've said here, for example, a valve colour, then with InTouch, you used to have to go back through every instance to change that colour. Now that changed a bit when we had the symbols, that they were centralised. The System Platform, if you want to change the scripts that are associated with the valve, if you want to add an extra point for that valve, for example, you may have a mid-position, then you only need to do that at template level, and that change is then propagated down throughout all the instances used in the application. Finally, a big thing about System Platform is you should script the objects to link automatically to the PLC. We talked about with System Platform, a lot of the work is in getting the templates right. They can derive their own scripts to link themselves to the PLC, so you just drag and drop, create an instance of that valve, for example, and it will know which PLC to link to, and link to that PLC. That's done via the script that's attached to the object. Now that can also be done for older PLCs where you may have registers instead of proper names. You may have to put a mapping file in that case, which can be loaded via CSV upload. So we're now going to run a demo. This demo has actually been pre-recorded. I shall run through the demo and explain it to you. So the development environment for system platforms is called the IDE. In this case, when you start up the IDE, it asks you which galaxy to connect to. Now, normally for a customer, we would recommend they only have a single galaxy. But for a system integrator, they might want to look after more than one galaxy for more than one customer. So they have that ability to select which galaxy they're loading from the IDE. So once you connect and start up the IDE, you bring up a standard dialog box for the IDE. This is basically split into three areas. A template area, and as you see here, we have a number of default templates. Those templates are that you get with the system. I don't know whether you can see me pointing at them, but we have at the top of the screen $Boolean, $discrete device. These are the base templates from which all other templates are derived. We also have templates, hopefully you can see under System, which are used to model the plant. So we have engines, which are used to run objects. We have areas, which are used for alarm areas. And we also have in-touch templates. We also have this device integration objects. We have other objects that you can download and load into the system, which will give you connectivity to the major PLCs like Allen Bradley's and Siemens. If you're using a third-party OPC server, we also have an OPC connectivity object, and we also have an in-touch proxy object to allow you to connect to in-touch applications to use that as the source of your data. There are some other objects available as well for connecting to things like iFix to use that as the source of data, and there are a few others. So we also here have a set of template objects that will be created for this specific application. One of the ones you see here is called reactor set, and that's what we call a contained object, because that contains the reactor and the storage tank. You also get the graphics toolbox, and the graphics toolbox contains about 500 ArchestrA graphics that you get by default, and they include all the common things shown here, such as fans and compressors. And they're free for you to use and embed into your application. So in the bottom view, we see how the objects are running and hosted within our application. So for example here, we have what's called the deployment view. This shows a single, what's called platform, which is a physical machine. Within that platform we have an engine, which is effectively a slice of processing time running, hosting the objects. And within that engine we have a number of objects. We also have a view engine which has an in-touch application associated with it. We also have a model view. Now a model view is where we start from really. This shows the objects that we have and how they're organised into their physical areas to represent the physical plant that we have. We also have a derivation view. And the idea behind the derivation view is it shows how our objects are derived. So here we have an R31 PLC object, which is derived from a PLC simulation object, and because it's prefixed with $, we know it's a template. That in itself is derived from the user-derived P template, which in itself is derived from a user-derived template, which is one of the base templates. So in this case, we'll go back to the deployment view, and we'll have a look at what's associated with that reactor template. So the first tab that we have are field attributes. So these are our mappings to our PLC. Now when I talked earlier about you configure the historian from this point as well, we've got that attribute, which is our reactor level, and all we've done is selected the Enable History checkbox. That's all we need to do to store the data. When we now deploy an instance of that object, it will create all the configuration that's required in the historian and start pushing data across to the historian. We've also selected for this level the alarm limits. And you can see we've selected high and low alarm limits, put in values and put in alarm messages. You see we've also got, which is something we don't have in InTouch, which is a time deadband available with the alarms as well. Now we also have scripts associated with our objects. This script that's shown here is where I talked about that the objects automatically link themselves to the PLC. This is done within this script here. Not going to go into any detail, but basically we're linking the input and the output of each attribute to a point in our PLC, or in this case, simulation object. We also have graphics associated with this object. So for example, here's the reactor display that's associated with this object. This is created using ArchestrA graphics. When you look at the links for this reactor display, you'll see that we're using object-based notation. So we're talking about me.mixer and me.reactLevel. You also see there's a little red mark or red check there against that object. That is because we've now got that object checked out. That object now is not available to anybody else to start configuring. So until we finish configuring that object, where we'll see in a minute, we check it back in, we are now editing that object. And when we check it back in this case, we didn't make any changes, but you'll see in a moment when we check it back in, we get the option to add a reason for making a change. So what we're going to do now is create a new instance of this simulation object. So we're going to call this R32_PLC. So we've selected to create a new instance. We then drag and drop it into the area that we want. And from this point we're going to then deploy it, which makes it active and makes it start running, makes all the scripts run on it. As I said before, when we're making a change, only the change we're making is activated. Everything else carries on running. We're now making a new instance of our reactor set, which we're going to call R32. And we'll rename that to R32. And again, we'll drag and drop it into the area that we want it hosted in this case, the demo area. And again, now that we've created that object, we'll make it active by deploying it. And this deploy in this case is to a local machine, but it could be to a remote machine on a remote site. And now we're going to paste the instance of the graphic that's associated with that reactor into our InTouch application. Now you'll notice we're editing the InTouch application from within the IDE environment. So we've got a blank screen here to add our ArchestrA graphic. We're going to select the graphic that's associated with that instance, paste it on the screen, and then resize it to match. But one of the things with ArchestrA graphics is they're vector-based, so they're resizable. If there's enough call for it, we may do an ArchestrA graphics WebEx in the future. So now we've added that graphic in, we'll save the changes to the window and close down InTouch. Because we've made a change, it's now prompting us for a comment to say what we've done. So in this case, we're saying we've added the R32 graphic. I will OK that. Now what it will do is go through and update the template and also update any derived instances of the template. So you can see this reactor demo, this deployed reactor demo application has now got a little icon appeared next to it. And that icon means that a change has been made to that application and that change is pending. So in order to make that change active, we then deploy that application. And again, this could be an InTouch application running on a remote machine on the other side of the plant. It takes a few seconds to deploy that application as it copies the files across. So now our operator, they would normally be running in touch. In this case, we're not running in touch. Just one point to note here, that we have a different application type. This application type is a managed application. Within Touch now we have three types of application. The standalone, which is a traditional application, a published application, which is an in-touch application that uses ArchestrA graphics, and this managed application, which is an in-touch application used in a system platform environment. We also don't have the window maker button available to us, because we have to develop our application from within the IDE. As we start this application, it'll prompt us to say a change has been made, do we want to accept it? If that was a running application on a remote machine, an operator would also get the same message to say that a change is available. He can choose to accept that change, in which case the new version of InTouch will restart, or he can choose to ignore that change. Maybe he's doing something quite important and he can't stop for that change. In that case, the pop-up box will disappear and reappear in probably an hour's time or so, asking him that he wants to accept that change again. So you can see here we've got the new instance of that screen embedded in the application running as Reactor 32. Now some of the other things that you get with System Platform is you get some maintenance tools that come as part of the Systems Management Console. The System Management Console is traditionally where you have the ArchestrA logger, so you can view the logs. But you also see with System Platform you have a platform view. That allows you to view the machines on your network, and you can start and stop the engines. And also there's single object viewer, which allows you to view attributes and current real-time values. And in order to back up a System Platform project, there's also a backup utility. And that backs it up to a single CAD file. So that's just a quick demo to give you an idea of what you get in System Platform and how you manipulate and use objects. Just take a quick look now on licensing. System Platform is licensed by a number of factors. Now the first one is I/O. Now, I/O in System Platform talk is the conversations between the System Platform and the devices it's communicating with. That is not physical I/O. The smallest you can buy is a 250 I/O, and it goes right through up to a 1 million I/O system. Within the System Platform, you also specify the historian size, so there are breakpoints for that. So, for example, with a 5K I/O system, you can have a 1K, a 5K, or a 25K historian system. Also, the number of platforms that you're running influences the System Platform. Every machine that's running needs a platform license. When you buy a System Platform, you'll get a number of platforms included with that. As it says here, you may also require extra licenses for I/O servers and InTouch. You get an I/O server with a System Platform. If you need additional ones, then they have a part number, and also InTouch doesn't come bundled with System Platform, you buy it separately. But it's a special version of InTouch called InTouch for System Platform. It doesn't have all the functionality of standalone InTouch. For example, it doesn't log its own data because that's done by the historian. It doesn't use InTouch security model because that's done by System Platform. And it doesn't generate alarms because again that's done by System Platform. So an InTouch for System Platform is a cut down version of InTouch, and it's also cheaper than a standalone InTouch. So if we take a typical system that we have here, we have two object servers, and these are redundant and they're linked together by the RNC, which is the redundant message channel. This is that back-to-back network link I was talking about. We've also got our historian server, which is also our Galaxy repository, and we have our information server. Now, for the purposes of this, I've split the historian and the information server so they can run on one machine. And we also have three InTouch for System Platform nodes and a development node. Now, the licensing that you'd require for that, and I've based this on a 5,000 I/O license with 1,000 history, you buy the System Platform, That would give you 3 platform licenses, which would be spread across each of the application servers and the information server. The historian doesn't require a platform license. You also get with that 1 I/O server license, which you use on one of the application server. As I said before, you get the 1,000-point historian license, and you get the information server portal license. So above that, you'd also require another I/O server license to run on the redundant application server node. You'd require 3 InTouch for System Platform licenses. Now they come with a platform license, and there's an option of having those with or without Active Factory, so that allows you to embed the Active Factory trends within the InTouch application. If you wanted a development node, you'd have to buy Development Studio, and if you wanted web users to connect to Information Server, then you'd need Information Server Client Access licenses. Just looking at a case study, Aena is an airport operator in Spain. It manages lots of airports within Spain, 15 big airports. They have systems within each of the airports for monitoring utilities within the airports, for example here, climate or runway. They felt that these systems were very bespoke, and whenever they wanted to make changes, they had to go to the client, to the supplier who'd made that system originally, which would cost them a lot of money. So they wanted an open system. They wanted it to look and feel similar to the system that they already had. They wanted it to be able to connect to multiple bits of hardware from different manufacturers. They wanted it to be user-friendly, and one big thing, they didn't want to be beholden to one supplier. And again, this just goes on from that. They wanted it to be compatible. They wanted redundancy to be built in as part of the system. And they wanted to be able to centrally administer the system. They were worried that some SIs would be against the technology. The way this was developed was Wonderware helped Aena develop a standard set of objects that would be used across all of the airports. They then appointed an SI for the particular installation, for the particular airport, and gave that integrator the objects that they developed. That integrator then took those objects and built the application that was relevant for that airport. So some of the SIs, as it said here, were against that technology. They were used to using their own systems. They'd also developed their own reusable technology, and they were seen as, they thought Wonderware were a bit of a threat. But the SIs did come around. Price and Kraft here said they were going to look at using this technology on other projects outside of Aena. Vanderland here, you can see how the first one took a month to develop, the rest were done in 4 days. This is due to the reusability of these objects. So it's now installed in 7 airports, and it's going live in other airports as we speak. So what was the value to them? Again, down to the reusability of objects. This reduced engineering time, allowed them to control the standards that they had within their system. So they could ask different SIs to implement the system, but using the existing standards made the systems all look and feel the same. This is just an example of the architecture that they used in the Barcelona Airport project, where they're using redundant object servers as well as redundant terminal servers for InTouch. So in summary, we talk about the 5 pillars of system platform benefits: the scalability, standardization, being able to reuse objects, the integrated system, and how it's centrally deployed and all developed from a central point. So if we look at InTouch standalone or InTouch with system platform, the fact that you can build applications as templates, you can build objects as templates, manage within the Galaxy, and look at the benefits, it's basically down to saving engineering time, reducing costs, and applying standards. centralized management. Okay, before we open up to questions, and just to let you know, the next WebEx will be on Tuesday, 17th of November, and we're going to then look at the Wonderware information server. Going on from that, we have another one on Tuesday, 24th of November, which is going to go through HMI reports. So I believe we're now going to open the lines up for questions.
Thanks, Paul. I'll just unmute the lines now.
Alicia has unmuted your line.
And we can open up for questions now. We have to go to hear you now. Any questions, Paul?
I have a question, Paul. You said that in the Aena application that Aena specified certain objects and these were made available to suppliers, integrators, OEMs, etc. Is that a trend that you're finding in the use of System Platform?
Definitely. I mean, it is a big part of System Platform. With standardization, you can create a library of objects, or the customer can hold a library of objects, or an SI can create a library of objects for the customer that has all the standard animations and the standard features that they have within their plant contained within those objects. And when they then need to extend their plants or create a new plant, they can then issue those objects, and you can export those objects from the Galaxy and issue them to the SI to reuse those objects. And it may be in some cases that those objects don't cover, again going back to the valve example at the beginning, every asset on the plant. There may be variations from those standard templates. But you derive templates from those standard templates that you've been given. So again, any changes that are made at the top level are propagated all the way through.
Okay, so the end user benefit would be a standard interface across all these facilities in case of the airport, and across all machines and production units in a manufacturing plant.
Yes, the interface as far as the operator sees should be absolutely standard because it's all built from the same Linux.
So you could redeploy labour a little bit more easily.
Yeah, and it's much quicker to develop because those standards have already been developed. You're not having to re-engineer the wheel again.
I think you answered, sorry, it kind of goes on from that, but I think you answered the question in the presentation, just to confirm that. You used the example of a global change, I think you call it, possibly not, on a colour change for a valve. Now, if you do that, would that automatically be deployed, or did I hear you correctly in saying it would be kind of deployed as information, and then the operator would choose to accept that change at a good moment within its process, for example?
Yeah, any changes that are made, including graphics, that change is then propagated through to that object, but doesn't happen immediately. So any instances of the object, you have a little icon on them which tells you that the change is pending, and then it's up to you to go and manually deploy that change out. In the case of an operator interface, you can deploy that change, and the operator will get a pop-up saying that a change is available. Does he want to accept it, yes or no? That behaviour as well can be configurable.
Okay. Thank you.
Any other questions for Paul?
No?
Yes, I have a question. Hello?
Hello?
Yes, it's you.
Yeah, it's Nicholas here. If you're doing a change to an object which involves scripting, for instance, which may change the control of an object and you're then propagating that throughout your whole plant, isn't there a safety aspect risk to doing that?
One of the things about when you make the change, as I say, it propagates through and it doesn't take effect immediately. That change only takes effect when you redeploy that object. So it's then up to you to do the tests on the template object to make sure the change you've made isn't going to affect anything or be dangerous. but you then can go and individually deploy those changes that have happened to each instance, test it, make sure nothing dangerous has happened, and then go through it in a methodical way. So it's not a big bang change that affects everything in one go. You get to say when that change is going to happen.
Right, okay, thank you. I've got another question, please.
Yep.
This system platform seems to have a lot of similarities in common with Rockwell Factory Talk. Are you aiming this at the same set of customers, or is it aimed at a slightly different area of the market?
I mean, there is going to be overlap, obviously, because we're both working within the same market sector. I must admit, I haven't seen Factory Talk, so I can't really comment on that. The System Platform now has been out for about the last 6 years as Wonderware Application Server. It's only in the recent versions that it's actually been all bundled together as Wonderware System Platform. I don't really know the Rockwell system to be able to comment on that. I would imagine that they are aimed at roughly the same areas. Does that answer it or not?
Thank you very much. Yes, thank you.
Any questions?
Any other questions? If there are no more questions, like I said before, this webinar has been recorded, so we will be posting it online on our website later on today, and there is a forum online as well. So if after you've had a look at the webinar or you've passed it on to colleagues and they have questions or there's any